Hello and welcome back to another episode of TÄCHES Teaches. I'm Tash, and in today's video I'd like to give a sort of broad overview of the main concept behind modular synthesis. Today's video is a direct response to a question asked by Peter Kaval yesterday on my sequential switching video about where to find resources to learn the basics of modular synthesis, upon which of course the grid is built. So without further ado, let's jump right in and see what's behind the curtain. The world of modular synthesis can seem really quite confusing at first, and it can become even more daunting in fact when you try things like the grid or VCV rack or reactor, because not only have you got all of these knobs and dials, but there's just so many options of things that otherwise you would have had to spend thousands of dollars to have all of these individual things, that suddenly they're all just there, and it's like, well, what do I do with that? What does this do? How does that work in conjunction with this? And this can be quite frustrating if you sort of have a background in music, because you see all of these cool videos of people making all sorts of beautiful generative or odd sounds with these synths, and it's a case of, well, what's happening? What are all of those things doing? Why are there so many cables everywhere? But really, every single thing that can be done in the world of modular synthesis is fundamentally because of one small concept, and that concept is voltage. I have here a knob mapped to an oscilloscope, and this will be representing our voltage control. Currently we have 0 volts coming into the oscilloscope, and if I put this all the way to the top, we now have our maximum value, which we're going to call 1 volt. A lot of actual modular synth modules will have different varying voltage amounts. You know, some of them will go from 0 volts all the way up to 5 volts, or some of them will be able to go down 10 volts and up 10 volts. But the way that we have this represented here in the grid is just 1 all the way down to -1, and that sort of stands as like a placeholder for just saying the maximum, the minimum, and the center line. Now, every single thing that happens in the modular synth world is purely a knob being moved in a certain shape, repetitiveness, depending on the speed, depending on how sharp the edges of this movement are. If I go up really fast and come down really fast, we're going to have a completely different effect than if I were to slowly rise and slowly fall. Now, the way that I want to explain this is sort of just without first going too much into detail of the modules I'm going to then explain about. I wanted to show you how we can replicate what those modules are doing with this voltage knob. And then I'm going to dive in a little deeper of how we then use those modules and what the main purposes of those modules are in a later video. But first of all, I want to talk about oscillators, because no modular synth setup is really going to be that useful if you're trying to make sounds if you don't have an oscillator. Now, we have a sine wave oscillator here, and by itself it doesn't look like it's doing much, but if I told you now that this is in fact just making music as we speak, all we need to do is tune in and listen to it, would you believe me? I'm going to take an audio output module here, and that will basically allow us to hear what we're doing. If I patch the output of this sine wave into the audio output, therefore to the speakers, we have a consistent tone. I'm going to disconnect it because that's going to become quite annoying, but I'm going to now put this into our oscilloscope and we can see there's our sine wave. There is that sine wave. And whatever changes I make to that will be reflected on this scope. But ultimately, the reason why we're hearing a sound when we patch this up is because we have a very fast alternating voltage. And I'm going to prove that to you by using this little setup we have here. Bearing in mind, again, there's no sound generating pieces here yet. This is just a voltage offset control knob. I can move it up and I can move it down. If I were to patch this to an audio out and I move this, you're going to hear a couple of clicks. And the faster I do it, the closer those clicks get together. And I won't be able to do it fast enough by hand, but if I were to wiggle that knob fast enough, we would end up with a tone. And how fast I wiggle that knob is then going to be dependent on the pitch. So if I were to take an LFO right now, and we'll get a little bit more in detail of how to use these and what these are, but if I were to take this LFO and I were to make it wiggle this voltage knob, and I were to make it wiggle it above and below, we can't hear anything at the moment. But as I start to raise this, in fact, I'm just going to turn it off for a sec, just so I can really blow your mind. As I start to raise the speed at which this is moving, we now have a triangle wave. And this LFO is simply moving this voltage offset so fast left and right that the clicks have come together to form a triangle wave. If I were to move this knob in a more smooth fashion using a sine wave, we now end up with a sine wave. If I were to move it up and down at sharp right angles to each other, we end up with a square wave. Okay, so we now know that an oscillator is simply a very fast moving voltage. It's going from 0, or it's going from -1 to 1, or whatever the actual spread is. It's going from its minimum value to its maximum value at a fast enough speed that those clicks have come together to form an oscillator. Okay, I'm sure a lot of you have used on some form of synth before an attack, decay, sustain and release envelope. And I'm sure we all know that by changing some of the parameters on that envelope, we change how the sound is played. A lot of the things that make instruments, like organic live instruments, sound the way they do and be recognizable is through their envelope. If we were to pluck the string on a guitar, we end up with a dang. We end up with like a sharp, quick transient, like a sharp one, and then it will usually just ring out. Or when you blow on in fact it would be a totally sharp dang. When you blow on a trumpet, for example, you go woo. It takes a while for the human to get up to their maximum blowing, but a trumpet could keep sort of a sustain going for a while. They could go boo. Ultimately, then they will get to a point where they have to then let go because of their breath running out. Or when you play a violin, you can smoothly bring it in, but a violinist can keep their instrument all the way up max value until they let go, but there won't be much release. Anyways, what is an envelope then? Well, if we go back to our voltage control here, if I move this up very quickly and bring it down slower, let's go back to our fast view here. What's that if that's not an envelope? Or what about that trumpet, Or what about our strings? Or our guitar? All an envelope is a change in voltage that's regimented. It's a calculated length voltage change that doesn't happen over and over again unless it's instructed to. If I take an envelope here and we output this envelope into this oscilloscope 2 and I trigger it, you can see here that we're getting a very defined shape there. If I take that output out actually, and I just use that to control my voltage knob, what we're now going to get is our voltage doing exactly the same shape. Fantastic. Okay, so in a lot of the modular synth world, you'll hear about gates. And gates are simply on and off messages. If we attach this gate module to the oscilloscope, you'll see that every time we get a gate signal, we get a sharp rise from 0 all the way to the maximum value that stays there for a little while before then coming all the way back down again. There's no ramp, there's no slope on the way down, it's just an on-off message. This is the equivalent of saying, do it now, do it now, do it now. And we use gates and triggers to start events or to trigger things to happen, to say, do it now, do it now, do it now. And gates are very often used with envelopes. because an envelope needs some sort of message to say, okay, I'm ready to do what I need to do, but just tell me when. So if we input a gate into an envelope, we then get that envelope opening and closing. But without some form of gate signal, an envelope is useless because it doesn't know when to rise or when to fall. And there's a difference between triggers and gates. We take a button here and we call this gate, and we take a trigger. A trigger is a quick rise, almost instantaneous, to its max value, and then all the way back down again. If I click this trigger button, you can see all we're getting is a line up. Now, triggers are used to trigger drum sounds, for example, or you can use it to trigger an envelope. If we now look at this tiny little trigger pattern here will trigger the whole of this envelope because it's saying, do your whole job. And then the envelope goes, okay, cool, I know when to start, now I'll just continue on. Whereas a gate is an on-off message where it can stay on. If I turn this on now, the trigger is just small and instantaneous. A gate is on and off until you then tell it. So an envelope with a sustain level, for example, which requires to be held, will benefit from using a gate. We rise to the correct level. I need to use this one actually. We rise to the level and then we fall. We rise, and as soon as I let go of the gate, then we start to fall. And again, we could just map these shapes with our voltage knob. Value, that's what I've called it. So, if we can then trigger an envelope with a button or a trigger, then why don't we have a look at ADSR here again. Let's take a sine wave. If we know that in order to trigger this with a button, all we need to do is turn that button on and it will stay there, perhaps we can just use this value knob in the same way. If I then bring this up, let's take the audio output to here. If I then bring this up, oh, there we go, we're holding. And as soon as I let go, let's map this over it. So this value knob just going high is a gate signal. In the same way that if we were to use an envelope that required a trigger rather than a gate, as soon as this goes to its high level, there we go. Okay, so I think that's a nice brief overview of voltage and control voltage. But I think there's one more thing I'd like to talk about before I finish up this video, and that is attenuation. Because a lot of what makes modulation in the modular world exciting is being able to scale how much of something that is being sent or received. If I were to take an LFO here and patch this out, you can see that this voltage is going all the way to the top and all the way down to the bottom. And as a way of explaining this, I'm going to take a sine wave and we're going to use this to control the pitch. And you'll hear a rather severe pitch change that's going all the way up and all the way down. And attenuation is simply saying, do that but on a smaller scale. So as I start to bring this down, look at the shape. So we've now attenuated that to a smaller level. We've attenuated a voltage to have less of an impact. It's also important to note that where you attenuate something to can be moved with what's called offset in the modular world, but in Bitwig it's called bias. If I want that same amount of attenuation but I want it to happen up here, I can just bias it. I can just move it to a different spot. So every single thing that you could do in the grid or on a modular synth is simply using voltages, using repetitive voltages like this to create waves, which could then be used to modulate things, or if we were to speed these up fast enough, we now know that to create pitch. Or if you were to slowly but surely raise up a voltage and bring it back down again, we can have envelopes. Or if you were to raise it very fast and come down, let's put this back to unipolar. If we were to raise this all the way up and then all the way down, we can make gate signals. Every single thing that you could do is simply playing with voltage. Anyways, I hope this video has been helpful, and I'm going to do a few more videos in the coming few days that will better talk about the actual modules involved, some of the common modules and the common uses for them. But this, I think, has been a nice brief overview of the main concept that will drive everything I will be teaching moving forward. Well, folks, that's all we have time for today, but I do hope that this video has been useful. If you enjoyed this little chat, then please remember to like and subscribe and leave a comment if you have any questions or ideas for future videos. If you'd like to take your support a step further, consider becoming a patron too. I'm also a Bitwig certified trainer in case you would like some one-on-one lessons on Bitwig, the grid or modular. And until next time, happy creating, friends.